It's been a minute since the last more junk video, but I think it's about time for another more junk video. And you know, when you got a seat belt around the CRT, you're in good shape. So we're going to pull all this stuff out of here. There's quite a bit, and we'll go through it. We'll test these CRTs. We'll analyze the stuff. I had to grab some records just for the kind of cheeseoid value for when I do record player videos. So we'll take a look at those. And I'll just kind of pull this stuff up one at a time and we'll go through it. Got a new degaussing coil there. A friend of mine was cleaning out his TV repair shop clean out service, and so it's kind of like get it or it's going in the trash. So I'm going to get this on a tripod, get on my bench, and we'll just start looking. This is kind of the first thing, and it needs to find a new home. It is a Predicta bottom with the top has been removed. The CRT was removed for something else. And I really don't do Predictas. There are people that do Predictas. One of them needs to purchase this. I'd like to get $50 for this, just because it cost me something. I had to exercise some goodwill. It's not in great shape. Looks like it has a Canada flag, and what is this other one? United Nations. That probably means it should go in the trash. Power transformer. Looks like the horizontal output tube is missing. The rest of it looks like it's there. No back. Probably pop this open and take a look at the flyback, but I don't think these flybacks go bad. Very, very rare. So it's kind of like, is that the chassis tin L43? I don't want to ship this. I really do not want to ship this. Unless you want to pay for my time to package it and ship it, but I bet this thing would be $100 to ship. Now you can't see it, but the flyback is in here and the tire looks decent, so I'm going to assume that the flyback is good in this one. So hopefully. Also notice it had these instructions on top of it. Maybe this was in a hotel, like a hotel motel set. I don't know. I think these were used in that application some. Anyway, let's dig into the rest of the stuff. This was kind of the only thing that I was going to try and hopefully find a home for. Chuck Mangione, Feels So Good. I believe everybody knows that song. Probably no one likes it. Ooh, now these are just for testing record players. Honky Tonk. Ooh, Joe Ryan. This has got to be good. It's probably not even in stereo. Let's see what we got here. This is in stereo. I like that. Dual dynamic stereo. Video All-Stars TV Jazz themes. Peter Gunn, everybody should know that. So this should be... Oh crap, it's empty. Oh well, it's a nice thought. I don't know why I grabbed that. Oh, here we go. Songs from How the Grinch Stole Christmas. This is definitely drum corps. International Championship. I wonder if this is copyright. Probably. Everything is. And then we got a new old stock degaussing coil. If you're not familiar, this is used to degauss color TVs that don't have automatic degaussing. Like I think CTC 15 and older. Demagnetizing of color receivers is required when color shading is evident or a portion or portions of the black and white picture. This color is caused by residual magnetism in the set and can be easily removed with the degaussing coil. It's also good service practice to degauss all sets before proceeding to align the purity and or convergence, since the magnetism may affect the final adjustment of these controls. So, 5-step process here to degauss a set. New old stock. Very cool. It's Thord Arson. Ooh, extended service life. How much service life would you expect to get out of coil wire? Chandelier bulbs. Yes, I have a light bulb hoarding problem. It's my fetish. I will deal with it. These are 40 watt, made in Taiwan, 130 volt, frosted for your pleasure. Couple bucks for the whole box, not a big deal. We'll use these in the dim bulb tester. Pull a couple of them out and put them in for the dim bulb tester. CRT socket adapters. Now, some of these I think are for my... I don't think this is. I think mine is a male. You know, I don't know. Well, that's kind of a cool adapter to have right there. It's kind of an all-in-one. Let me grab my tester real quick. So this is the 467. And this uses, this uses female. So I believe like this one would go to this. Yeah. So some of these will go to this and some of them don't. That one does. That one does not. I don't know, maybe this goes to a CR70. This one does. This one does not. Alright, so I've sorted these out. These go to a different tester that I don't have yet. This very well could be a Beltron? Really? Do I have this? I might. Let me go get the Beltron. Oh, baby, I think I do have this. So here it is. Okay, I think. So this is it, huh? Yes, these do fit. So I have like the complete, a lot of the Beltron adapters here for the Beltron, which I don't even really like to use the Beltron because the Beltron doesn't tell you if there's shorts in the CRT. Check this out. This is a brand new old stock new tone AM FM transistor music intercom system. Wow. Phono, AM, FM, 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 AM, FC, AM, FC, FM, AFC. Stutter, point, bark, rash. This looks very American made. How awesome. Look at this. It's got the hardware kit, FM tuner. Wow. New tone INC. This is pure American made class right here. Okay, we got a couple CRTs to test. We actually got 3 or 4, but we'll start with this one. And I believe this is a fresh rebuild or new old stock. I think that's what this plug is, kind of. And then we got one of these with the metal bell. These like to go to air quite a bit. Not high. Ooh. Would it ring like that if it was gone to air? Would it sound different if it had air in it? You would think the vacuum would dampen the ringing, but maybe not, because it's equal all the way around. Anyway, you can kind of tell the amount of hours on a CRT by looking at the rear cup. You can see that one is pure silver, so this would almost suggest that this is a unused. It might be a rebuild because it's Pioneer Electronic Corp, Santa Monica, California. I didn't know they had a CRT rebuilder in Santa Monica. I know we had Dunbar in downtown LA. That one looks like it's got some hours on it. See the discoloration? Okay, this is the metal bell. Let's see what happens here. Usually if they're gassed out, they'll just blow the filament out and there'll be no emissions. No, it's glowing. There it goes. Go down to 5 volts, see what we get. Drops off, but not a lot. So, is it gassy? I don't know. Okay, let's try the other one. So if I had to guess, this is like a 12 LP4 maybe? Is that the right number? No number on it. See the difference there? It's come down to 5 volts. It's come down to 4 volts. See what a good strong CRT looks like? Come down to, well, that's as low as it'll go. Now look at it, it's still pegged. Jeez. Yeah, I would say that's new. Unfortunately, it's got some scratches in the front, which kind of degrade the value. This one is a 17 YP4. And this one has a little bit more discoloration on the rear gun there. You can see it's a bit browner. So let's see what this one has to offer here. If it's dead, it go in the trash. Oh, must have heard me. I mean, it would work. It would produce a picture. I'll think about if I want to keep that one or not. Kind of weak. Okay, here's the next one. This is a Zenith 16VBFP22 color, and this is not loading the voltage down. The pins on this are very dirty, but I tried to sand them, so let me, yeah, I got the other tester on it here, and look at this, that's a cutoff. This is a brand new CRT. Too bad I don't have any Zenith sets that use a 16-inch. Look at that. Look at that. Let's go down to 5 volts here. Let's go down to 5 volts. Hardly any drop at all. That's a brand new tube. I wonder if the case got smashed or water damaged or something. Wonder why they pulled that. That's a brand new tube. All right. Next on the, I shouldn't have brought it home, but I did, list. This looks like another 12 LP4. And this looks like RCA with this style of coil. And this tube looks relatively low hour. And it's heavy. 100 pounds, 120 pounds. And it is a RCA KCS 34B. Model TC127. There's probably someone looking for one of these somewhere. It sure would be nice if they were here to adopt it. The only reason I took this is because it makes me breathe heavy, and I know that turns some people on carrying at 500 feet. No, I thought it'd make an interesting resurrection. These make excellent pictures when they are restored properly. And restored properly here, it probably will not be, because they have so many capacitors that have to be changed underneath. Let's see. Try and lift this. And here's my point. This is a paper capacitor leakathon. Well, let's test the CRT, and if it's good, what are all these wires for? So what did this go to? Speaker, or... But you can see it's been sitting for a long time without tubes in it. Alright, here we go. wonder why it's pulsing. If you look at the... Oop. It is glowing. Why no happiness here? That does not look like a high hour. That does not look high hour to me. Oh, there it comes. Boy, that's sad. That's really sad. I'll let it sit here for a few minutes. But if the tube is not strong, I might just pass this off to the metal guy. I got a bunch of these, and I got so many sets around here to resurrect. I bet I got 20, 25. Okay, well, this is pretty tired. And you can tell by comparing this to the same 12LP4 we tested earlier. I got to think about this if I want to move forward and try and resurrect this thing. It's been sitting for a while, and you don't want to let them sit too long because it's just driving current through the CRT. It'll just burn what's left of the cathode away if you let it sit there in test mode. So ideally you don't want to do that. But yeah, it's pretty tired, and we can tell by comparing it to the 12LP4 we tested earlier how weak it is, how that one would just bang the needle at 4 volts. So I got to think about whether I want to resurrect this or not. These are a lot of work, a lot of hours, and generally when something is not in a cabinet, it is not as appreciated as if it was in some type of cabinet where it looked like a TV, not just some type of electromechanical contraption sitting at a science fair. So anyway, those tubes don't look like they were pulled out that long ago. But yeah, I mean, we got a chassis number here to go off of, but we're missing several vacuum bulbs. It's probably the 1B3. So I don't know. Might resurrect or might give to scrap metal guy. The rest of what I grabbed was just flyback stuff, and I thought I had found a bunch of the U-bolts that hold these together that I see breaking on the Trinitrons, and I can't find them here. These are all horizontal coils for look like tube color sets, like that's the RCA efficiency coil. This is the focus coil. I don't know what these are, efficiency coils, but yeah, big box of these. We actually have notes here on what they are. Looks like someone was doing some testing here. This all looks like it was for Admiral sets. Bunch of flybacks here. See, these are those U-bolts that are breaking in the Trinitrons. So it looks like somebody was custom making flybacks or high voltage transformers, because these only have really a primary and a secondary. They don't have... Oh, look at that one's broken. So these bolts are breaking on everything. Let me unfold this. 1974. Why is that guy like dressed so... what would you call that? Upstanding? Why isn't he sagging his pants and all gangstered out? Wow, those would be considered domestic terrorists today, dressed in that denim stuff. Anyway, $2.44, 100% cotton material, sizes 9 to 24 months. Oh, look at, here's your stock market. Airplane. More flybacks. More flybacks. Someone was making flybacks here. That pisses me off I didn't get those bolts. I could swear that more flybacks. They're obviously for a tube set because they got the filament winding right here. But it's interesting they only have 2 windings on them. Primary and secondary. There's no windings for the yoke or anything else. Very odd. And then here we got just a bunch of parts. Zenith parts. That's in a horizontal coil or an efficiency coil. Convergence balance coil. So all those little things that you... Oh, a Huygebeimler. This is to weigh the weight of a record player. Tone arm. You hook this little hook. Let's see, what can we hook here? Nothing. We have nothing to hook. But you hook this little hook under the tone arm, and then you lift, and it tells you how heavy your tone arm is. This is before digital. That's kind of cool to put that in with my record player stuff. But yeah, there's just a ton of stuff like that in here, and I saw convergence amplitude coil. I saw something that made me think I know about what I should be when I was there with myself. But I don't know where it went. Some high voltage. Oh, here we go. A cassette. Who knows what a cassette is? Sights and sound schematics. Introduction to video cassette recording. I think this has to have a date with the player. In fact, maybe I just go get that. You think this has copyright on it? Let me make sure I got everything here, and maybe I'll just go get my little player and let this roll. Oh, here's something that's real practical today. Just, you know, lots of parts, and they all have to be sorted in spreadsheets, or you don't know you have them. Guess I got a few things here I need to add on to this more junk video. Not quite sure exactly what this thing is and what it does. This is definitely for a roundy CRT. Not really sure what this is. Is this a microphone or a light sensor? Almost looks like it goes on a mic stand. And then we got made out of metal. BK model 850. Guess maybe I could take the time to look that up. Color analyzer. And what is this? Is this a little CRT in here? So we got this right here, which is a mirror. Video, power, gun killer. That's handy when doing, what do you call it, your purity. Color, that's sort of interesting, and pattern. I'm going to open this real quick. Let me get a screwdriver. We make open. Okay, gimmick point cigarette xylophone. So you have that window right there, right? So this is the pattern that shows up. And this is the color. Ultra gimmick. I mean, I guess it's kind of cool, but we'll try it out on a color set in the future, but super gimmicky. Wow, look at all these transformers. Ooh, shaky, shaky. Look at that ground wire wrapped around that transformer. Alright, next thing is a tube caddy. I needed just an empty tube caddy for a bunch of stuff bunch of tubes I bought off of ESRC. Before that, yeah, sadness happened. And I didn't really even need the tubes, I just need the caddy. Too bad it's missing the handle, but the 11BM8, the bowel movement audio output tube. Got some tripplers here. I'm going to do a video converting an old color TV to a tripler, where I stripped the secondary winding off the flyback. So what we've got here, what is this? This is a what's this? That looks like a CTC 15, right? CTC 15 flyback or clone. CTC 15 clone, something like that. LU8, isn't that the Sylvania vertical output tube? It's a big Yeah, that's the Sylvania vertical deflection tube. Which someday I got a couple Sylvania sets I want to do videos on. I got so much I want to do. 30JZ6. 30JZ6. That's horizontal output, right? Ward's Airline. Let's see who makes it. Looks like Sylvania. Yep, Sylvania. See the way the numbers printed on there? So, tripplers, flybacks, tubes. And I'm going to take all this other stuff out, put tubes in here, and then make spreadsheets of it. Alphabetize it all. And then I think this is definitely a score. This looks like all the adapters for the BK Precision 467. This is the CRT tester I was using with the 3 meters. Let's take, ooh, I even got the roundy socket. God, these are dirty. That's okay. $50 volts at 680. And I split these with a friend. 56 microfarad at 200 volts. These will come in handy. These will work for AA5 radios. Guy wanted 20 bucks for the whole bag. We split it. They're probably counterfeit. Who knows? Maybe they're not. I'm going to lay all these adapters out. Let me see what numbers we got here, because that would be excellent to have the entire set for that tester. So this is totally ridiculous here. Of course, I have all the books. Some of these are custom made. I have all these books here, but it's interesting looking at this. Look at how many number ones there are. These are all number ones. 2 number 2s, 1 number 3. See, is there a number 3 in here? No, there isn't. That's kind of strange. Look at all the number 4s. These are all number 4s. Are these bad? These are probably for the standard 25 XP, 25 AP. This is a number 3. Oh, maybe I do have more than one number 3. Okay. Look at all the number 5s and 6s. I mean, I don't get it. Why are there so many? I mean, did they wear them out? Anyway, this makes happy because this will help complete. And then these are all the other numbers here, like 36. Here's some homebrew. It's like they ripped the socket off of the neck board. 15, 37. So yeah, this is quite a score. I wish I could find all the cables for my color jig. That would be really cool. 'Cause yeah, I want to start working on more color stuff. I've been thinking about it a lot lately. Early, color tube sets. Yeah, I got to figure out how to divvy these up. Maybe I need to get a good CRT and go through just to test the sockets. Alright, we got our trusty Caliphone classroom cassette deck here. Indestructible. So we have Zenith Sight and Sound Schematics 1982. I have no idea how much time is left on the... Let me make sure I'm in low resolution. Alright, here we go. Looks like I got an hour, so I can drive everybody nuts that wants to watch.
Zenith Radio Corporation presents Sight and Sound Schematics. Introduction to Video Cassette Recording. Please refer to the diagrams in the technical manual that is part of this Sight and Sound Schematics package as you listen to this tape. Stop the tape whenever necessary to check diagram references. Restart the tape when you're ready. Basics of video recording. Basically, videotape recording employs the same principle as audio recording, using magnetic means to record a signal onto a tape. However, there is a great difference between the audio and the video signals that are recorded. Audio has a frequency range of approximately 20 Hz to 20 kHz. Video has a much greater and higher frequency range, from about 30 Hz to 4.5 MHz. The highest frequencies are necessary for picture quality, the lowest for sync pulses. The source of the video signals can be from a television camera or from off-the-air broadcast signals. Frequency limitations. The gap effect of the heads is the most important limitation on the range of video frequencies that can be recorded and played back. Figure 1 illustrates this effect. It is a curve of the playback frequency response. As the signal to be recorded rises in frequency, a steady increase in the played-back signal occurs. This rise is at the rate of 6 dB per octave, an octave being a doubling of frequency. This rise in output continues until a maximum is obtained. The frequency where this occurs is indicated on Figure 1 as F sub M, that is, the maximum frequency. Beyond this frequency value, the output will rapidly drop, reaching zero at twice the frequency of maximum output. The points of F sub M and 2F sub M are determined by the size of the head gap and tape speed. The more narrow the gap is, the higher will be the frequency for maximum output. But a very narrow gap restricts the output at the low frequencies. See Figure 2. The speed of the tape movement past the head also affects the frequency response of the record playback system. The greater this speed is, the higher will be the frequency of maximum output, but the lower will be the signal output at the lower frequencies. The audio frequency range of about 10 octaves, 20 Hz to 20 kHz, applied to the output curve of Figure 3, shows the 20 kHz limit equal to 2F sub M and the low end, 20 Hz, at a very low level of output. The frequency of maximum output would be 10 kHz. Frequency compensation to raise the low and high ends of the curve and reduce the middle can produce a more constant output with frequency. Several different methods have been employed in audio devices for this compensation. A frequency range of 10 octaves is about the maximum range that can be practically recorded and played back with compensation. The approximate range of video frequencies to be recorded and played back for television purposes, 30 Hz to 4.5 MHz, is 18 octaves. The signal output curve for a head designed to give maximum output at 4.5 MHz would show the 30 Hz output down about 110 dB. These extreme differences of signal level would make compensation and equalization of output at all necessary frequencies impossible. Some other method must be used. FM video recording playback. If the range of frequencies for video recording and playback, an overall difference of approximately 4 MHz, is converted to a higher frequency spectrum, the ratio of the high and low video frequencies can be greatly reduced. For example, see Figure 4. If the frequency spread were changed to a variation between 4 and 8 MHz, the difference being about equal to the video frequency range used, the frequency spread becomes 1 octave rather than 18. If the head gap is designed for maximum system output at 6 MHz, the outputs at 4 MHz and 8 MHz would be down only a small amount and equalization would be easy. The frequency variations in the video signal could occur within this altered frequency spectrum, that is, by frequency modulation, FM. Frequency modulation of the video signal to be recorded and played back is then the answer to the video frequency response problem. For example, a high-frequency sine wave strong enough to saturate the tape becomes the carrier for the FM process. This carrier is modulated by the video frequencies. The lowest frequency corresponds to the sync pulse tips, with the highest corresponding to peak white. The actual frequencies selected for this method of FM vary from recorder to recorder. FM systems also strictly control the signal amplitude levels, thus reducing noise problems. This is another advantage of the use of FM in the recording playback process. The high carrier frequency used for the FM signal process requires a small head gap and high tape speed. The high tape speed, of course, means fast consumption of the tape, and therefore large reels. In most cases, this is an impractical situation. Also, the high tape speeds are difficult to control, complicating the drive mechanism. This method of recording by moving the tape past a stationary head is called longitudinal recording. This is the method still used successfully for audio recording, but not for video recording. Transverse recording. Longitudinal recording results in a recorded magnetic track that is along and parallel to the length of the tape. Another method of recording that uses much less tape is transverse recording. This method produces tracks across the tape at almost right angles to the length of the tape. See Figure 5. The head is not stationary in this process. It moves across the tape at a relatively high speed, as the tape moves rather slowly past the head mount. The result is a high head-to-tape speed, also called writing speed. This idea of a moving head led to the development of rotating head mechanisms. 2 or more heads are required for this operation. Head A is recording a track on the tape, while Head B is retracing or returning to the top edge of the tape for its next track. When that position is reached, Head A is switched off and Head B is switched on. Thus, properly timed switching is another requirement of the rotating head and transverse recording process. During the playback mode, proper switching and positioning are very important to ensure that the heads retrace the exact paths made by the heads during recording. Servo systems have been developed to control the head positions, another requirement of videotaping. Small irregularities, lumps or holes in the tape coating that are not much of a problem in audio recording become serious in video recording. They can cause loss of contact between the tape and the head, resulting in incomplete tracks on the tape and temporary loss of the signal on playback. This signal loss is called dropout. It may appear as horizontal flashing on the screen, a portion of a line or up to several lines in duration. Surface bumps on the tape, dirt or residue on the heads, or non-regular tape motion can cause this dropout condition. Video recording requires the maintenance of precise contact between the head and the tape at all times. To ensure this requirement, a slight penetration of the tape by the tip of the head is employed. The best example of transverse recording is the quad head recorder, a large and complex and expensive machine, much used by the broadcasting industry, but not suitable for use by others, including consumers. The speed of the tape and the tension on the moving tape must be very steady to guarantee reliable signal recording and especially accurate, steady playback. Obviously, tape tension control is another requirement of video recording playback. Helical video recording. A videotape recorder that is simpler and smaller and less expensive than the quad head machine is one that employs the helical scan method of recording and playing back the video signals. See Figure 6. In this method, the tape wraps around a large drum that contains one or two heads which rotate in a plane parallel to the base of the machine. The tape leaves the drum at a different level than it approached it. See also Figure 7. The movement of the tape is along a spiral or helical path. The track that is recorded on the tape by the rotating head is slanted and longer than the path for transverse recording. See Figure 8. The head drum diameter and the tape width can be designed to make the recorded track long enough to include a complete TV field at high writing speed. The electronic circuitry required for head control and switching is much simpler than for the quad head recorder. Figure 4 indicates the development of the slanted tracks on the tape with this helical scan method. These tracks contain the video information. Control and audio tracks are recorded in a longitudinal manner along the two edges of the tape. As shown on Figure 9, the recorded tracks slant to the right on the tape, as viewed from the side away from the drum. The same tracks, viewed from the other, or oxide side, which contacts the drum and heads, appear slanted to the left, as in Figure 14. The spaces between the recorded tracks are the guard bands. They eliminate crosstalk between tracks. The width of these guard bands is determined by the speed of the tape and the width of the head gap. Helical scan videotape recorders have become dominant in the non-broadcasting applications of video recording. Although many different models and formats have been developed and used, the basic principles are the same for all helical machines. See Figure 10. The tape leaves a supply reel, passes over a tension arm, past an erase head, around the head drum, past a control head and audio head, and through a capstan and pressure roller to the take-up reel. Figure 11 shows the relationship, time-wise, between the tracks on the tape and the video information recorded on the tracks. Switching between the heads occurs during the few lines just before the vertical sync pulse. Color recording. In this previous discussion, we have described in general form the requirements and methods for recording and playing back the luminance or black and white video signals. The first videotape recorders recorded only black and white signals. In time, methods were developed that permitted the recording of color signals also. The NTSC signal spectrum appears in Figure 12. The basic requirements for a system that would record and play back color information would include the following. 1. Compatibility with black and white television. 2. Processing of the NTSC signal within the same bandwidth as used in black and white video recording without changing the tint of the color signal. Two methods have been used in the recording of color signals onto tapes. One method is called the direct method. The other is called the color under method. In the direct method, the NTSC signal is coupled to the FM modulator, just as is done with the black and white signal. The color signal consists of an AC 3.58 MHz signal on a DC level. The DC portion of the signal determines, through the FM modulator action, the carrier frequency for the video and color signal modulation. The AC portion of the signal produces sidebands of this FM carrier. The color signal can be readily demodulated just as a black and white signal is. One problem with this direct method is that the sidebands on demodulation can cause interference beats in the picture. The color under method, shown in Figure 13, separates the color and luminance signals from the incoming signal. Each portion of the total signal is processed individually. The color is heterodyned down from 3.58 megahertz to a lower carrier frequency and recorded directly onto the tape. The FM carrier is used as a bias that is amplitude modulated. During playback in this method, the color carrier is recovered and heterodyned back up to 3.58 megahertz. That concludes side 1. To continue, please turn the cassette over.
All right, this is, I'm going to speed this up. Ooh, pink. I'm going to speed this up a little bit. I hope it doesn't annoy anybody. I guess you can slow it back down with the YouTube player on desktop. But yeah, this thing has a speed control. Here we go. Get this thing cranked up a little bit.
Color playback.
Here we go.
The successful playback of color signals recorded onto the tape is a more critical operation than that for black and white recording playback. The important problems of color playback are as follows. 1. Tension changes in the tape movement. 2. Tape stretch. 3. Wow and flutter in the tape movement. 4. Servo instabilities and corrections. 5. Noise problems in the signal. And 6. Beats in the picture. If these effects occur, tint can change or color can be lost or interference bands appear in the picture. Thus, some means of correcting for possible color problems is a definite requirement for color recording and playback machines. Requirements of color videotape recording playback systems. Among the basic requirements of a reliable, successful color videotape recorder machine are the following. First, properly timed switching of heads. Second, properly positioned heads. Third, tape tension control. Fourth, continuous head-to-tape contact. Fifth, crosstalk reduction. Sixth, correction or avoidance of color recording or playback problems. Seventh, steady head rotation speed. And last, eighth, steady tape movement speed. The beta format was introduced in this country in November 1975. It is a half-inch wide tape cassette system. 2 video heads are used, with full-frame recording. Figure 14 shows the beta format recorded track pattern. The recorded, slanted tracks of early helical scan machines were 60 microns wide, such as the Zenith JR9000 and the KR9000. At the fastest tape speed, beta 1, a guard band, as in figure 9, was present between tracks. At a slower speed, beta 2, the tracks touched with no guard bands. In more recent machines, tracks are narrower, about 35 to 40 microns, and a slower tape speed, beta 3, brings the tracks together. This is acceptable because of 2 well-devised arrangements that reduce the crosstalk effects. Luminance signal crosstalk from track to track is avoided by the slanting of the 2 head gaps relative to the tracks. This is called the azimuth technique. Color crosstalk cancellation occurs because of a more involved signal phasing system involving a comb filter. Figure 15 is the recorded signal spectrum for the beta system. The VCR will record and play back the video and audio signals that may come from one of 2 sources. One possible source is a received television channel. The other is the output of a television camera and a microphone. This video and audio information is recorded on the metallic oxide coating of special tape by magnetic means. The tape used has a width of 1/2 inch and various lengths. This tape is packaged in a small, slim cassette whose dimensions are 6.1 by 3.8 by 1.0 inches. Figure 16 is a picture of the cassette.
The audio track stores the audio information recorded. Some method is needed to synchronize or time the tape information so that the playback mode reproduces the exact audio and video signals that were recorded. This is the purpose of the control track, which is laid down on the tape as indicated in Figure 14, a representation of 3 types of tracks. Both audio and control tracks are longitudinally recorded. The diagonal lines are the recorded tracks of the video information. Each track is one vertical field containing 262.5 horizontal lines. This method requires 2 heads to record one complete frame. With the advent of the video cassette recorder, technicians must acquire new skills, both in theory and mechanical areas. Servicing is aided by the abundant use of integrated circuitry that collectively performs a multitude of functions. The fastest way to service the unit is to know the signal paths in both the record and playback modes. Figure 17A shows the antenna input to either the splitter and then to the TV monitor or to the UHF-VHF tuners in the VCR. When the picture source switch is in the TV position, the antenna signal, through the splitter, is routed to the television monitor for normal viewing of the received program. The tuner of the monitor TV receiver is simply tuned to the channel selected. In this mode of operation, there is no signal coupled to or through the VCR. With the picture source switch in the tape position, Figure 17B, the signal from the antenna is coupled to either the VHF or the UHF tuner in the VCR, through the IF circuits, onto the video system. The video signal is sampled, as the E-to-E or electronics-to-electronics composite video signal bypasses most of the VCR circuitry and is coupled to the RF modulator. This modulator provides an RF output of the sample signal converted to either channel 3 or channel 4. This output is connected as an input to the appropriately switched tuner of the monitor television receiver. Thus, the actual program being taped can be checked during the recording process. The recording process. See Figure 18. The output of the tuner is fed to the IF system, where it is amplified, detected, and AGC and AFC voltages developed and the video and audio detected. The audio is sent to the audio block and to the audio head, which lays down the audio signal onto the tape. The circuitry on the audio board has the same general arrangement as that of a common monophonic tape recorder. It includes a record playback preamp, a line amplifier, a record amplifier, and a bias oscillator circuit. The audio input is set up to accept either line level or microphone level audio signal inputs. The composite video signal, developed within the IF block, is divided and proceeds in 3 directions. One connection is to the servo system control block circuits. Another connection is to a YC circuit board, where the video signal is used in 2 ways, for luminance and for color signal processing. Another connection to the luminance signal path routes the video through the YFM modulator block. A developed AGC signal automatically regulates the level of the input signal to the modulator. The video signal is then fed through a 3.58 MHz trap circuit and now becomes the luminance signal. Luminance is subsequently converted to an FM signal by the FM modulator and then is coupled to the 2 recording heads through the adder. The third video connection is to the chroma signal system, a color under system in which the chroma portion of the NTSC video signal is down converted to 688 kHz from 3.58 MHz. This is achieved by heterodyning a 4.27 MHz signal with the 3.58 MHz and using the difference signal, 688 kHz. This signal is then processed to develop the automatic color control, ACC, and the automatic color killer, ACK, voltages, and then coupled to the video head. Both the frequency modulated luminance and the down-converted 688 kHz color signals are combined in the 2 video heads, which produce the recorded video signal onto the tape. The video signal input to the control circuit activates drum servo and pulse generator integrated circuits. The servo system controls the speed of the head drum, and the pulse system produces switching signals used in switching between the two heads. The vertical signal, which has been separated from the composite video, is passed through an integrator network to extract only the vertical sync pulse. The output toggles a flip-flop, which divides and shapes the signal into a 30 Hz square wave. This control signal is recorded onto the tape. Playback processing. On playback, the video, chroma, and control signals are taken from the video heads and processed and routed through an RF modulator with an RF output on either channel 3 or 4. The video signal, YFM, is picked up by the video heads, sent to a YC circuit board where it is amplified, de-emphasized, limited, demodulated, and sent to the RF modulator, which gives an RF output on either channel 3 or 4. The chroma signal picked up from the video head is converted back to 3.58 MHz. Any crosstalk or jitter is attenuated and ACC and ACK voltages developed. The chroma is then added to the luminance signal, coupled to the RF modulator, and out of the VCR to the TV monitor. The control track on the tape is picked up by the control head and amplified. The speed of the head drum is servo-controlled by comparison against the playback controlled signal. In the beta format system, the guard band between adjacent tracks has been reduced to 0 at low tape speeds. Two comparatively new techniques are utilized to reduce crosstalk. One principle of this technique is based upon the inherent loss of high-frequency playback response, which occurs when azimuth misalignment exists between the record and playback head gaps. The phenomenon is well known to most technicians who have made head azimuth adjustments in audio recorders. The angle of both the record and playback head gaps to the recorded track must be the same, or high-frequency response is lost. See Figure 20. In two-head helical scan VCRs, the adjacent track on each side of the track being played back at any given instance is always a track recorded by the head not in contact with the tape. Thus, crosstalk can be attenuated at the relatively high luminance FM frequencies by deliberately introducing an azimuth displacement between the two head gaps. If the two video heads are designated A and B, see Figure 21, sufficient azimuth misalignment is introduced to nearly eliminate YFM crosstalk by setting the gap azimuth of head A plus 7 degrees and that of head B minus 7 degrees. With this technique, each adjacent track effectively becomes a guard band. Although the total 14 degrees azimuth error between the two heads is sufficient to nearly eliminate crosstalk between adjacent tracks for the luminance FM frequencies, which lie between 3.5 and 4.8 MHz, it is not great enough to eliminate crosstalk for the lower 688 kHz chroma frequencies. This problem is overcome by using a special chroma recording technique. The basic concept of the color recording system in the beta format VCR is a color undersystem, in which the chroma signal is separated from the luminance, down-converted to 688 kHz, and recorded by the video heads in a frequency band below the lowest frequency of the YFM deviation. See Figure 22. To attenuate chroma crosstalk, the chroma signal goes through a complex filtering and phase inversion process that will not be covered here. The result is much reduced crosstalk and enhanced chroma. A second important feature of the chroma circuits is that the frequency relationship between the sync and chroma portion of the signal is maintained during recording. This in turn greatly improves the locking range of the system. The technique for chroma jitter and phase correction takes advantage of the fact that the recorded relationship of chroma to horizontal sync is preserved, and uses the separated playback horizontal sync as a pilot signal for jitter detection. For detailed information on specific models of Zenith video cassette recorders, refer to service manuals and any training tapes covering these products. This is the end of the audio recording portion of the Sight and Sound Schematics Introduction to Video Cassette Recording.
Boy, did anyone stick around through that? That's pretty much nerdgasm. Anyway, I was showing this, which was an EOL thing, and if you've never worked on a VCR, and I used to, and I never will again, this is the, so it pulls the, these things go into the tape, and they pull the tape out around the spinning head here. I can't see what I'm showing, but this is the spinning head, and there's two heads in here. There's one right there, and there's one here. Some of them have 4 heads. You can see the little head right there. So these go into the tape when you put the tape in, and they pull the tape back here. They pull the tape out of the cartridge. Here's the erase head right here. And so this is the spinning, and you can see it's sitting on an angle, the spinning head. And then this is the, I forget what this is. This is the audio head, but I think it does something else. This is the capstan, and then it comes around. This comes over here and pinches. This comes over here and pinches the tape up against the capstan, and then it comes back on the take-up reel. And yeah, this is something that there's probably guys out there that work on these. This one was a victim of pink smoke or red smoke, and I just kept it, and it's interesting that I found that tape. This was something that used to be very complex, and right at the end they were very simple and much more reliable. Anyway, where do I go from here with this video?